So yesterday we talked about finding domain and range when you had a nice clean endpoint. This is just a quick refresher of what we did yesterday. These graphs had a very clear beginning and ending, and we could say it goes from here to here, left to right, and here to here, up and down. Okay? What we're looking at today, and this is in your notes packet, so you'll want to make sure that you're following along here, is we are looking at graphs that don't end. We are looking at infinite graphs, okay? So you'll notice all of these graphs have arrows on the end of them. All right, and I'm actually going to start with this middle example and then move up to that one at the top. So normally we would say, what's the farthest point to the left and farthest point to the right? The problem is, because of this arrow, it goes further and further to the right the further down you extend this, and technically that extends forever. Okay, so what you really need to say is there anywhere to the left there that this graph won't hit? So imagine if I built a wall somewhere over here, okay, and that wall was infinite, so imagine my purple pen went on and on forever. Would this arrow eventually hit that purple pen? And the answer is yes, it would, because it's going to continue to kind of curve out here to the left, and if it went down a little bit further, it's eventually going to intersect that purple pen. All right, let's do the same thing to the right. So over here on the right, will that other arrow, the arrow on the right, eventually hit that pink pen? And again, the answer is yes. And there's no gaps or anything in between. So for this one, I'm going to say that it hits everything, which in math speak is all real numbers. Okay, so my domain here is all real numbers because this graph covers every possible x value. Okay, now let's look at range. Range is the same idea. Normally we would find the highest point and the lowest point, but it's impossible to find the highest point because this goes on forever. So again, I'm going to ask myself, if I built a wall up here and if I built a wall down here, would my graph eventually touch both of my pens? The answer is yes. And then, are there any gaps in between? No. So my graph covers everything. So again, all real numbers. Domain and range here, all real numbers. So now let's go back up and talk about this one up here on the top. Okay. Domain. So again, I'm looking left to right. So I'm going to build my walls on the left and the right. And I want to know, will my graph eventually hit my pens? Yes, it will. So that's all real numbers. And for range, I'm going to go up and down. Well, up above, my graph will eventually hit this purple pen. So up is no problem. But look down here. Do you see how this graph stops right here? So it's never going to hit this pink pen. So when you get a spot where the graph will not touch, you have to figure out how far in that direction does it go. What's the lowest point that this graph is going to hit? That's this right here, which is -1 on the y-axis. And so I want to say this graph covers everything from -1 up. All right, and mathematically, that means everything greater than or equal to -1. Because greater than or equal means heading up when you're talking domain and range. Okay? Let's try one more. Let's try this very bottom one. Okay. This bottom one is talking about a graph that's finite on one end and infinite over on the other. Okay, so that's kind of strange. So for domain, again, I'm going to go left to right. Now to the right here, that graph will eventually hit that pink pen, but it won't hit my purple one because it stops right here. So I want to say, what's the farthest point in this direction that my graph hits? That'd be this right here, and that's 1, 2, 3, 4, -4. So I want to say everything from -4 up. Well, and it's not technically up. Everything from -4 to the right. But then think about that means the numbers are getting bigger, right? On the x-axis, as you go to the right, the numbers get bigger. So for my domain, I would say all real numbers greater than or equal to -4. Okay, because it goes from -4 and then everything in this direction. For range, when I build my walls above and below, eventually, see how this graph is slowly getting higher and higher? So even though you can't see it on this paper, eventually this graph would get up high enough to intersect this pen, if the pen went on forever, okay? So up is no problem. Down, though, it does have a minimum point. It does have a lowest point, and that, again, is this point right here, but now I want to look at it in terms of up and down, okay? So the lowest my graph goes is, let's see, I've scribbled all over here, but that's a 2 on the y-axis. So I want everything from 2 up. Okay, everything from 2 up this graph will cover. So I'm going to say all real numbers greater than or equal to 2. Okay. So that's how you handle it. Your answers are going to look different when you have an infinite graph because you're typically talking about either all real numbers or all real numbers greater than or less than a certain value, as opposed to the specific intervals that you had before. Okay? So now you do have another assignment, I believe, listed in Blackboard for you. You can go ahead and get to work on that, and I will be checking these notes for points when I see you again.